Good afternoon to my friends and also to our Dr. Ujila. And today we are going to do we are gonna discuss about the script file that we already done for our MATLAB assignment. And first, I will introduce myself. My name is KENSON John, and this is Tan, and this is ANUWIN. But we only three of us that can that's still in UPM, so only three of us that we're gonna do this big presentation, yeah. Because other group member was absent because they have some problems and they already went back home. So I'm gonna first talk about this script file. Yeah, the first things that we must do before we can do the script is first we must do two functions. That is, first we do the x function, that is this one, the equation that we already given from the question, that is 4 cos 2t minus 2x over 2y, and this is the dy dt, that we differentiate from the initial equation. And the second equation that we must use is for dx dt, that is only y. And after that is we must do the combine both of this function. That is, first we recall back this function by using function. Also, the txy is the constant or the value that we use in this equation, and this x1 y1 is the initial value, and h is the increment, and a initial value of time, and b is the final value, and f1 and f2 is the function 1 and function 2 that we already done before. And first, we must to do this Euler method, we must use loop function. That is, we use 4. That is, first this is the first equation, that tn plus 1 is the increment of time, and the fx1 fy1 is to find the value of each increment of time, and fx2 and fy2 is after we add increment of time. And the equation that we use for Euler method is this one, the one that doctor already teach us. And that's all for the function. And next, my group member will explain about the plotting graph.
Good afternoon, doctor. My name is Tan, so I'm going to explain about how to plot the graph for the Euler method. So, as you can see, this is the method for MATLAB to plot those graph for Euler method. So, and this is dx dy. It is actually the function from before that KENSON said, and this value 0, 0.6, 0.10 is actually the initial value. And we type this plot px, and it will become the x against t graph. And we put the title Euler solution. So I will run the program, and the graph will be like this one.
This one.
So you can see this is like the graph for the Euler method is x against t. Okay, that's all for Euler method. So my friend ANUWIN will continue.
Hello, my name is ANUWIN, and I'll be talking about the comparison of value in this
from this question. Okay, now you can see from this coding we have done, Euler methods, using the Euler method, this dy are the initial given values for this question, and we have set our t, which is our time, from 0 to 0.5 with an increment of 0.1, which means it will go from 0.1 till 0.5. So we have come up with two methods, which is the analytic method and the Laplace transform for this question. Both has the same equation, which can be seen as 12 divided by 25 times to the exponent t plus 6 divided by 5 times to t by times to exponent in bracket negative t minus 12 per 25 in square root, and that value is times by cos 2 times the time t plus with 16 over 25 and times with sine 2 with 2 times the time t. So this equation is derived from dy dt from the earlier equation. And next, the Laplace transform has also the same equation, because when we derive we get the same thing. And thus we have plot the graph using this coding, and the graph title is graph of x against t, which was explained by Ji Hong just now. And now I'll run this, execute this file, and we'll get a graph of this is the graph. So as you can see the graph over here, the graph has a very minute, very small change in the difference between the Euler's method, which can be visible from here to here, and slight deviation of analytical method and Laplace transform. This is because from our calculation we know that the deviation from here is equivalent to, when the time is equivalent to 0.5, its percentage of error is 0.13565%. So this proves that the deviation is very small, and that's why the graph looks almost the same. It's very similar. And that's it from us on our presentation today, and thank you.